Hello students, good morning. Welcome to my lecture on chapter number 10 Halogen derivative class 12 science Maharashtra State Board New Syllabus 2020. In the previous lectures we have completed about SN1 reaction mechanism and SN2 reaction mechanism. Now today we are going to study elimination reactions. So let us study elimination reactions. Before going to study elimination reaction, you must know some points related with what alkyl halide. Here we have to concentrate on alkyl halides only. I am writing one structure. Try to understand this structure. Suppose here I am writing Dia. See, this structure called ethyl bromide. See this carbon atom. This carbon atom is attached to bromine atom. So this carbon atom is called as what? Alpha carbon. And to this alpha carbon atom, this carbon atom is attached. So this carbon atom is called as what? Beta carbon atom. Similarly, this hydrogen is attached to this alpha carbon. So it is called as what? Alpha hydrogen atom. And this hydrogen atom is attached to this beta carbon atom. So it is called as what? Beta hydrogen. This one is also beta hydrogen, and this one is also beta hydrogen. And see, this one attached to alpha carbon, so it is also alpha hydrogen. Similarly, you also remember one more point. That is removal of hydrogen atom. Removal of hydrogen atoms is in the order see, first tertiary hydrogen is preferred, then secondary hydrogen is preferred, and then primary hydrogen is preferred. In this manner, hydrogen atoms are removed. You remember also this order also. I hope you understood alpha carbon. Alpha carbon atom is what? The atom which is attached to hydrogen atom. It may be Br, Cl, I, X, etc. So this carbon atom is called as what? Alpha hydrogen. And to this alpha carbon atom, the carbon atom attached, that carbon atom is called as what? Beta carbon. And the hydrogen atoms attached to alpha carbon, they are called as what? Alpha hydrogen atoms. And here these hydrogen atoms attached to beta carbon atoms, so they are called as what? Beta hydrogen atoms. So we will start. These reactions, they are also called as what? We will study dehydrohalogenation. Of what? We are going to study dehydrogenation of alkyl halide. Alkyl halide. Now, D means what? Removal. Hydro means what? Hydrogen. This is what? Halogen. Halogen means dehydrogenation involves removal of hydrogen and halogen. I hope you understood the meaning of dehydrogenation. Now, this dehydrogenation is also called as beta elimination. Beta elimination. Why it is called beta elimination? Because it involves removal of beta hydrogen from alkyl halide. This is also called as 1-2 elimination also. 1,2 elimination. Why it is called 1,2 elimination? First thing is what? It involves removal of halogen atom from alpha carbon, as well as it involves removal of hydrogen atom from beta carbon. Now go through this. We are going to study dehydrogenation, that is also called as elimination of alkyl halide, which is also called as beta elimination because it involves removal of beta hydrogen. Now it is also called as what? 1,2 elimination. Why is it called 1,2 elimination? Because it involves removal of hydrogen atom from alpha carbon and removal of hydrogen atom from beta carbon. See, it is hydrogen, it is alpha carbon, and here hydrogen and beta carbon. So let us start the reaction. Now for this we can write simple reaction. Take C H H H C H H X. But before going to study this, you must remember what are the conditions. Suitable for elimination. First, generally tertiary alkyl halide. Tertiary alkyl halide prefer elimination reaction. Second, it requires strong base, or we can say rich electron species. That is strong nucleophile. And last one is what? It requires less polars for one and high temperature. We already studied about nucleophile and electrophile. See, nucleophiles, they have tendency to donate electrons. Now these are the conditions suitable for elimination. So you know that tertiary alkyl halide prefer elimination reaction, but primary alkyl halide undergoes what? Substitution reaction. Here tertiary alkyl halide is most preferred for the elimination. Now see this. I have taken here ethyl halide because there are two carbon atoms and CH3, CH2, X. X means what? Halogen. X means what? Halogen. It may be X means what? Chlorine, bromine or iodine. Follow this. Now see, this carbon atom is attached to X, so it is what? Alpha carbon, and this one is what? Beta carbon. Remember that. What happened here? We are going to take what? We'll take alcoholic KOH. And what? Heat. Now what happens here? It contains CH bond, means it, see, these are the two electrons. Here again there are two electrons. Two electrons means what? One bond. What happens here? This bond is break. So what will you get? What is remaining? You have hydrogen having one single electron and H having single electron. So you get what? HX. HX, and these two electrons, they can form a bond. So what will you get? CH, CH2. This bond is already exists, and one more bond is formed due to these electrons. So here you get what? Alkane. It is what? Alkane. And hydrogen halide is formed in this manner, HX. So what happens during elimination reaction, the preferred product is what? Alkene. So how do you write down the statement? When alkyl halide having at least one beta carbon, is boiled with alcoholic potassium hydroxide, then halogen atom is removed from alpha carbon and hydrogen atom is removed from beta carbon to produce alkene. Now this reaction is not possible for methyl bromide. Why? Because there is only one alpha carbon atom. This carbon atom is not attached to any other carbon atom, so methyl bromide do not undergo elimination reaction. I hope you understood this part. Now come to the example. Let me change this. I will put here, for example, I will put here Br, methyl bromide. So what will you get? Here you get what? HBr, and this product is called as what? Ethene. This is the example of elimination reaction. Now we will proceed for next part. We will consider different example, and we are going to study new concept, that is what? Set-Z rule. Set-Z rule. This also involves dehydrogenation reaction. What happens here? I am taking your simple example. Secondary butyl bromide. Here H. It is what? 2-bromobutane. It is what common name, and sorry, it is IUPAC name. Common name can be written as what? Common name is written as what? Secondary butyl bromide. See, it is what? Common name. Now see, we require alcoholic KOH. It is necessary. Now what happens here? First of all, it is alpha carbon. We can put here it is beta. We can put here beta 1, and we can put, I will write here beta 1, and it is beta 2. So there are two possibilities for the removal of hydrogen from these beta carbon atoms. If we consider beta 2, so what happens? This part will eliminate it. Eliminate means what? Removal. So what will you get? You get CH3, CH2, then CH double bond CH2. This is called as what? But1ene. Now consider this. If you consider here you get what? HBr. If you consider beta 1, Here you get what? Removal of beta 2 hydrogen. Okay. If you consider removal of beta 1 hydrogen, what will you get? Beta 1 means HBr is removed. So here we got CH3. What is remaining? CH. Here again CH. And here you get what? CH3. It is what? But 2A. You know that, see, it is 1, 2, 3, 4. After first carbon atom, there is a double bond, so it is called but 1A. And see here, 1, 2, 3, 4. Here, what happens? Double bond is after second carbon atom, so it is but 2A. Now, here what is remaining? HBr. Now, we have to find out which is the stable product. Here, Syllabus states that what? States that in dehydrohalogenation, the preferred product is that alkene in which greater number of alkyl groups attached to doubly bonded carbon atoms. Now see, here C double bond C, CH double bond CH2. This is what? Carbon double bond. Now to this carbon atom, CH3 CH2, that is what? Ethyl group is attached. Means here only one alkyl group is attached, so it is what? Here it is what? Minor. Why it is minor? Because see here, CH double bond CH. These are double bonded carbon atoms. Here it is what? Methyl group. Again here this is what? Methyl group. So two methyl groups are attached, and therefore it is major. So according to Syllabus rule, but2ene is the major product. Now we will proceed for next. I hope you understood this. Now we are going to study reaction with active metals. Active metals may be sodium, magnesium, cadmium, etc. So let us start with reaction with active metals. Next part, reaction with active metals. First we consider action of magnesium with magnesium. Now what happens here? Before going to study this, first you have to understood the magnesium metal. Magnesium is what? Divalent metal. Divalent means what? It has two valencies. See, so it is divalent. So it can form two bonds. I hope here we can put here R alkyl group and we put here halogen. So here magnesium can form bonds with alkyl group as well as with halogen atoms. So it is also called as what? Alkyl magnesium halide, which is also called as what? Grignard reagent. Grignard reagent. This reagent was discovered by Grignard, so name is what? Grignard reagent. And for this invention, for this discovery, Grignard got Nobel Prize, and it is very useful in the preparation of many organic compounds. Now, how is it prepared? So, reaction with magnesium metal. You know that RH, that is what? Alkyl halide plus magnesium. This reaction is carried out in presence of what? Dry ether. So, what will you get? Simple RMgX. First, this bond is break. So, R having single electron, X having single electron, and here you get what? Magnesium. This way. So, you get what? Alkyl magnesium halide. Alkyl magnesium halide. This is called as what? Grignard reagent. Grignard reagent. Sometimes you are asked what is meant by Grignard reagent. First of all, Grignard reagent is an organometallic compound. See, we'll first take one example and then we'll study the meaning. Take CH3Br, that is what? Methyl bromide plus magnesium. This reaction is carried out in presence of dry ether. So what will you get? CH3MgBr. It is called methyl magnesium bromide. Now here what is given? See, it involves what? CMg bond. This bond is called as what? Organometallic bond. So, Grignard reagent is an organometallic compound in which divalent magnesium metal is attached to alkyl group as well as to halogen atom. So, that is called as what? Grignard reagent. Now, here we are using dry ether and dry magnesium metal. What is the reason for that? If you use moist condition, then what happens? If you use moist condition, then what happens? We'll see. RMgX is very reactive. It's very reactive, so it can easily react with what? Water. See here. You get what? RH plus MgXOH. So instead of alkyl magnesium halide, you get what? Hydrocarbon. And therefore we require dry ether for the preparation of alkyl magnesium halide, because dry ether absorbs all the moisture. Now, I hope you understood this reaction. If this alkyl magnesium halide is treated with methyl alcohol, then what is the product? Methyl alcohol, then you get what? RCH3. That is again what? Hydrocarbon. And magnesium attached to X and OH. Similarly, if RMgX reacts with what? Ammonia and H3, then you get what? This can be written as H and H2. You get what? RH plus MgX and H2. Again you get what? Hydrocarbon. Now consider next reaction, that is what? Worst reaction. This reaction already studied in 11th standard, that is what? Reaction with sodium metal, Na. Now it is very easy. When alkyl halide is treated with what? Sodium metal in presence of triether, what happens here? This R combined with this R. This alkyl halide is what? Lower alkyl halide. In this reaction, lower alkyl halides are converted into what? Higher alkane. Plus what? 2NaX. It is what? Higher alkane. See the example. If you put CH3Br plus 2 sodium plus CH3Br. Here again we require dry condition because sodium is very reactive towards moisture. So we must use triether. Again here what happens? See, methyl combined with this methyl group. So we get what? CH3, CH3. It is what? Ethane. Plus 2NaBr. It is called as what? Methyl bromide. Methyl bromide is the lower alkyl halide and ethane is the higher alkyl. Higher alkane. Means higher alkane contains twice the number of carbon atoms as present in lower alkyl halide. See here, in methyl bromide only one carbon atom is present, but in higher alkane two carbon atoms are present. If you put CH3 CH2Br, then you get what? CH3 CH2Br, CH3 CH2Br plus 2Na plus CH3 CH2Br. Here again what happens? See, ethyl bromide contains 2 carbon atoms, so product must contain 4 carbon atoms. So here you get what? CH3 CH2 CH2 CH3 plus 2NaBr. That is what? Butane. Butane is the IUPAC name and common name can be written as what? N-butane. Now we will study different reaction, different example. If you take CH3Br plus CH3 CH2Br, then take any, we'll balance that afterwards. Triether. We'll balance afterwards and put here 6Na and here we require methyl bromide, ethyl bromide. I have taken here different alkyl halides. Then you get what? Mixture of alkane. See, first take first take methyl group. You get what? Methyl plus methyl, ethane. Then you take this ethyl group, ethyl, you get what? Butane. And then take one methyl and this ethyl group, you get what? Propane. So you got what? Mixture of alkane when you carry out the reaction with different alkyl halides. Now it is balanced. Here we get what? 6NaBr. I hope you understood this part. Next time we will study reactions of halogens.